All right. So it says that we have this ability to restore or roll back an object to its previous state. The problem to solve: consider an item. In our case, item over here was drawn as the originator over here. Considerable hidden state information. Considerable means, most likely considerable means a combination of data attributes. Like in the savings account, the interest rate, the actual balance, and other sometimes customer specific settings. So it's really a combination of of parameters that contribute to the overall state of that object. So the client who wants to run this transaction in the system, they want to remember the checkpoint states, preserved states, right? So checkpoint is basically well-recognized achievement in that process, right? So anytime we succeed, before we attempt the next series of changes, we want to preserve the state, and that would be referred to as a checkpoint state, right? So checkpoint state is saved. Now we want to modify the state, and if something happens to go not the way it's expected, we may want to be able to roll back or restore to the previous checkpoint state. And sometimes you can go all the way to the original state before the transaction was starting up. So and so therefore this item piece here, we want to basically have an absolute minimal impact on the original on the original item in case if we have to restore back, right? So we want it basically to preserve the object and the state of that object. And things can get a little bit more complicated when there are multiple items affected. Like with the savings and checking account, you'll now have two accounts that you want to preserve. Do you preserve them in sequence? Do you preserve them at the same time, both in one in one of the checkpoint states? It really depends. It's your choice. But you have to recognize these checkpoint states that needs preservation. All right. So the solution is here, and we can basically look at this diagram, that this item or the originator basically has the state, and the set memento and create memento, the two classes create this memento, which you can see captures the copy of the state. And I apologize that this UML diagram is actually flips the methods and the data attributes. I need to correct this because the data attribute section typically follows the name of the class and not the methods, right? So, but ignore that for now. We can fix that later, right? And so the caretaker simply, its first responsibility is to keep track of the memento class instances, right? So when we say in the originator supports create memento, which basically returns new memento, right? And of course preserve its state in the memento class, and then and it has the set memento method, which basically takes the memento as a parameter and restores its own state, right? So over here is, on the diagram, the state is shown as only one item, but most likely when you need those mementos combination, most likely you have the combination of data attributes and not a single attribute. All right. So the caretaker right here, we said that the caretaker implements the undo mechanism, right? So it's the caretaker is the one who is responsible in the system to be able to find the correct state and give it to set that state back, and therefore can roll back a transaction. Right, and as we said, the responsibility to store memento objects in memory. So the caretaker is the one who aggregates the collection of the mementos. So the caretaker never operates on or examines the contents of the memento. Right, it really is the set state, get state methods inside the Memento that know this, private and detailed knowledge about how to handle the state, how to capture the state, and how to restore the state. The caretaker really essentially delegates all the work to individual Memento classes, class instances, and they are responsible for working with the state. So the caretaker only works at the level of, I have the mementos and I can facilitate this preservation and the undo mechanism, but I don't know much details about the states, right? So there's just a clear separation of the responsibilities. All right. So moving on. So basically that's the organization. And here's a very, very, very brief type of demo. This is actually like a C++ class named Memento here, and it basically says that I can access the item or the originator, and I can and my constructor basically will capture the state, and so the item then can ask can have these two methods to create memento and restore the memento, and uses these two methods. So this is the description of what is available in all of these classes. So the item, we say, is the originator of states, which need to be preserved. And so the create memento, restore memento is commonly referred to as caretaker, right? So the caretaker basically will be managing these for the item when the item or process is requesting the restoration. So this is an interesting thing that we want in our diagram. When you go back, we really don't want the mementos to be created casually by other parts of the system. It's really the originator that should be, when it says create memento, only this method should be actually manufacturing a new instance of the memento class, right? So this is just a requirement of our design pattern over here that we deal with. We might also want to allow incremental restoration via stack of mementos. That would be responsibility of the caretaker, and it's possible to implement memento file or database or serialization. We could, instead of just preserving the memento objects in memory, we may also have the caretaker, and part of this get state and set state functionality, we can also save this information, save this state in the database, right? We can preserve it somewhere in the serialization file, or not just necessarily in memory, because what if the system crashes in the middle of all of it? We want to be able to actually then restore the state of the system with the caretaker and a list of mementos, this time restore it from the database, and then attempt to continue or attempt the rollback as required to undo whatever has been already done but not finished due to a system crash or some other unforeseen circumstances. Right. So that's just these are the typical requirements and implementation details. Right. So the observer. This is now the new pattern, the observer. I thought we're still talking about the memento design pattern. So we can write some of this code just to demonstrate the dynamics for the memento classes. So I'm already starting my IDE, and we can then continue on with this example.